Keith Casey. I'm a developer evangelist with Twilio. So I already said what Twilio is, but just to put it on, on the record, we're a telecom company. We sort of enable applications to be able to plug into the phone network, not like mobile apps like iOS or Android that you might think of. Instead, it's like the phone network, like placing phone calls, sending text messages, or receiving and reacting to phone calls and text messages. So that's all I'm going to talk about that specifically. But tonight I'm here to talk about REST best practices. REST is fun. It's sort of like I think of REST in terms of similar to a cloud. And I don't mean cloud as in, oh, look, cloud computing. I mean cloud as in that thing you look in the sky and everyone sees something different. It's kind of how REST works. So with that, so like I said, I'm Keith Casey, developer evangelist with Twilio. I'm a general annoyance, right, Josh?
I think that's been covered already tonight.
Yeah, okay. Yeah, I think I've demonstrated that. But I lead an open source project called Web Project. It's the best project management system out there. I might be biased. And I run around agitating an awesome PHP, doing all kinds of things. But what's funny is despite doing all that stuff and having fun doing it, there's one thing that I seem to be getting known for more and more, and that's for my relationship with the TSA. I think that and the hashtag sort of speak for itself, so I'll move on from there. All right. So when we talk about REST, we actually have to rewind a little bit. We have to go back to the beginning. In the beginning, when we were developing applications, say, mid-90s into early 2000s, every application lived on its own. It had its own data, it had its own thing, it had its own authentication, and there was no collaboration. There was no sort of central repository of data that we were pulling from, which was good in a lot of ways. I mean, like we were talking about security vulnerabilities that happened over the weekend with Amazon, Apple, and all that. Well, when the systems aren't communicating, that's a lot harder to do. So, there's an upside to that. But there's a lot of downsides too, because we want to be able to share data. We want to put it together. And primarily, these were applications built for humans by humans. From there, we said, well, sharing some of this data is useful. So people came up with the idea of SOAP. Has anyone actually read the SOAP spec?
It's terrible.
Yeah, exactly. I actually worked for the federal government at the time, and we were doing some early SOAP stuff. And it's funny because we printed it out one day, and it's like 300 pages. I mean, it's a freaking novel into itself. And
you know that it includes a spec for the option to do SOAP requests over email?
I missed that part, thank God. Yeah, so SOAP is sort of like the end-all, be-all. And actually, I think the way SOAP came about sort of doomed it from the beginning. Because a lot of the standards that we see that sort of get worked out, it's a bunch of people all using something in similar ways, and they sort of sit down and say, hey, are you doing it like this? I'm doing it like this. If we do it like this, then our things are more compatible. SOAP is the exact opposite way. A bunch of guys got together at a high level, and they said, this is how it shall work. I mean, and they came down, SOAP was written in stone, and they came down from the mountain, and they said, hey, look, this is how it's going to work. Yeah, that didn't work. It turns out people don't like that. It's amazing. So this concept of REST came about. And actually, REST came about in Roy Fielding's dissertation in like 99, 2000, I forget the exact year. And he said, hey, look, fundamentally, we need to stop and think about the web in a different way. SOAP request, that's basically RPC. We're talking about remote procedure calling, and that's kind of silly. If we sort of stop and tear the web apart and we look at it in a different way, we can say, well, if something is RESTful, which means that sort of there's no state shared, everything is a resource and you can interact with that resource, then, well, sort of a handful of requirements, a handful of constraints pop out of that. And what's interesting is this is where things sort of go haywire, because there's 6 REST constraints, I should say. But if you actually stop and ask anyone, hey, you have an API, is it RESTful? The answer is yes. It doesn't matter what they're doing, it doesn't matter what they say, the answer is yes. And it's not because that's the correct answer, it's because that's what they've been trained to say. And it's really kind of a miserable experience. And so the concept of strictly RESTful or REST-ish, it's all bullshit. It does not mean anything at this point, because it means exactly what that person wants it to mean and nothing more. But the problem is, if Dan and I have a conversation, he uses it one way, I use it another. We think we're using the same word, but it's not there at all. There's no commonality whatsoever. And so we have to remember that REST is not a standard. There's no formal specification that goes behind it. There are specifications for the pieces. So if we talk about HTTP, that has a standard. If we talk about SSL, that has a specification that goes behind it. But REST itself is not. And so the sort of analogy I use here is that SOAP is like a mortgage. To be able to get a mortgage, you need to provide a lot of documentation up front. You have to provide all this information in a certain way. You have to provide it to these certain people in a certain order. And when something goes wrong, there's a very clear procedure on how to resolve it. Maybe not the way you want it resolved, but there's a way of resolving it. REST is like borrowing 10 bucks from your buddy. If I go up to Dan and I say, hey Dan, I forgot my wallet, can I borrow 10 bucks?
No.
Okay, so he's smart. He's smart. He's going to say no. But somebody else might be foolish enough to say yes. We'll say Brian's foolish enough to say yes.
Sure, Keith.
Sure, Keith, yes. And, well, this is done on a handshake. This is done just because there's enough trust that he's, well, imagine there's enough trust that he can go ahead and give me $10. Now, if I don't pay him back, is there a process in place of resolving that? Is there a process in place to sort of figure out what the repercussions of that are? And the answer is no. I mean, sure, I might avoid him at the next meeting. I might not, might not respond to his email, but there's not a formal process. So REST is that. REST is a handshake agreement. Fundamentally, we do not have a spec like SOAP. We don't have a mortgage. There's not that good, that big structure in place. And I slip good because sometimes that's good. If we're talking about sharing medical information, SOAP makes a lot of sense. You don't want that sort of thing as based on a handshake deal. You want that documentation. You want to know, when I get into this error state, what happens? REST, not so much. So, just to kill off one thing real quick, REST has nothing to do with URLs. Absolutely nothing to do with URLs. Everyone says, hey, look at my RESTful URL. It's / this, da, da, da. You know what? Bullshit. I'll say it again. Everyone sort of got the idea that REST was pretty URLs from the Rails framework. Rails generated these pretty URLs. Everyone said, hey, look, it's RESTful. No, that's totally unrelated. What happens is REST is an architecture. REST happens behind the scenes. Does anyone know how to do pretty URLs? One quick and easy way? Mod rewrite.
Yeah.
Mod rewrite does pretty URLs for us, right? Does mod rewrite imply or define anything about our architecture? No. It's just a little processing thing before it even touches our architecture, right? So URLs have nothing to do with it. Absolutely nothing to do with REST. They can be used for a RESTful application or a RESTful interface, but they are not necessarily part of it. The other thing is XML and JSON. If you actually go back to Roy Fielding's dissertation, it says nothing about what the payload actually is. It does not have to be XML, it does not have to be JSON. That actually has nothing to do with it. And there's some other constraints that go with it, but these are not part of it. So just because somebody's pushing XML over a URL that happens to be pretty does not mean anything. It's actually probably closer to RPC or SOAP than REST necessarily. So the problem that comes along with a lot of this is that since REST means exactly what I want it to mean and nothing else until you start thinking of it, a guy named Steve Klabnik, he's a really sharp Ruby guy. He was actually at the Rails meeting a few weeks ago, and he's speaking at ToledoCon in October, so there's a plug. He said, look, we need to stop talking about REST. Since it means everything to everybody, all we're going to end up doing is shouting at each other. And unless you can shout louder than everyone else around you, wait, that doesn't work either, right? So instead, he says we should stop talking about REST and we should talk about this concept called Hypermedia APIs. And this is where things get interesting. Now, don't tell anyone this. It's actually the same thing. But the problem is REST is such a loaded word at this point that if we use that, people are going to make a lot of assumptions. So let's just throw it out and act like this is a brand new word and it means something totally different.
And it's happy.
Yep. Huh?
Happy?
It's happy.
HAPI.
Actually, what's funny is Hypermedia is actually hated because the abbreviation is Hypermedia as the engine of application state, or also as Hadios. So Hadios is the best cereal ever. All right. So when we actually talk about REST, the reason we care about it, going back to the core principles here, we care about the utilities. These are what's called the system quality metrics. So we want to know that something it has simplicity, it has stability, it has upgradability. These are the things fundamentally we care about. If it matches the REST constraints, hey, fantastic, great. But at the end of the day, this is the stuff that actually makes that check appear in our bank account. We want to know that things are reproducible, scalable. Now, at the end of the day, there's really a handful that us as developers actually care about. and that's the ones in red. We care about, is the system available? Is it stable? Is it scalable? Is it maintainable? Is it extensible in the right places? When things break, is it debuggable? Reliable, hopefully it's usable. Hopefully. And then is it flexible? And obviously these terms, they all have some meaning, but the degree to which they are each of those things really depends on what we're talking about. I run an open source project, it's a project management system. So our system has to be super extensible because every group has its own sort of concept of what project management is. It also has to be very reliable. When you put your data in there, you need to know that it's going to come out in a way you expect. But the interesting thing is it doesn't have to be very scalable because it's project management. The vast majority of the time, it's going to sit within your organization, so it's not going to be on the public web. It doesn't have the scaling constraints that like Basecamp or Twitter has. It needs to scale for your organization, that's it. So, those things, they have some squishiness in how much we need to consider those. All right. So now with those sort of illities in mind, let's go back to the core constraints. There's 6 of them that makes up. This is the first one, client-server. We know what client-server means, right? Does anyone need to know what a server is? Okay, cool. But what it fundamentally means is that we've got 2 components. And once we've got 2 components and the means to communicate between them, we can start varying them. That's why we have a web server and a database server. And that's what allows us to upgrade the database server and not worry about changing the web server. In simplest terms, that's what we're talking about. And then it also goes on the other side too. We have a web server and we have a browser. When somebody upgrades their browser, do we need to upgrade the server? Do we need to upgrade their browser if somebody upgrades the server? No, we can sort of totally separate those. And the cool thing is that now that we've separated those and we can vary those independently, we can also expand them, we can upgrade them, we can scale them as necessary. I mean, we don't care how many servers Facebook has, as long as when we hit that button, it comes up. We don't need to know anything about it, they handle that. Next one is stateless. And stateless is one of the things that we as web developers struggle with. Cookies are a state. What happens is that when you come to a website and you log in, well, if that server knows that you're logged in, it sets some sort of session. And then you come back and whenever you've got your cookie or whatever, it authenticates and says, oh yeah, this person's logged in, and they let you go. The problem is that is not very good at scaling. Because now you've got one server. Well, one server is pretty easy to do. You just use whatever shared session, you can put it in the database, whatever. Doesn't really matter, but it's really easy to do that. But once you have 2 servers, then what do? Because this memory is not the same as that memory. And has anyone ever hit that problem where they click on a site, they go and they log in, and then they're clicking around, all of a sudden you have to log in again? That's what you run into, is that the session is over here, and now for some reason you connected to another one that doesn't remember you're logged in. So there's a couple different approaches. One of them is using something like a shared memory, like a memcache, and putting that session there. So now you can have a whole bunch of web servers all interacting with that. You can also do that with a database. You can do a thing called sticky sessions. So that means once you authenticate with one, all of your future requests go to that one, which works out really well until that server goes down. And then what happens? Well, if a router is really dumb, it keeps sending you there, and it's dead. If the router is smart, hopefully it's going to send you to another server, but then you need to log in again. That pisses people off. I mean, fundamentally, how many people have to click on the site and they log in multiple times and they just go, oh, stop it, and they just go on. They close the site, they move on, they use another service, whatever. We don't want that. Those are some of the problems that state causes. So what we need to do is we can remove state from the equation and say, hey, look, everything is stateless. Web server, you don't need to care that I'm logged in last time. I will give you enough information to log me in again. And you do that repeatedly. So this is what it actually looks like behind the scene, or sort of at the interface level what you're doing. This is just a requested Twilio. It's nothing all that interesting. It's what it takes to send a text message. The key part is this part in red. So it's -u, that's user. AC is an account sid, that's your username. And auth token is your password. Each and every request sends that. So what happens is if you're communicating with server number 1 and you're sending your stuff and getting responses, if server number 1 disappears and server number 2 comes up, well, each message is complete unto itself. So now you can hit server number 2 or 3 or 4 or 600 and nothing cares. Because each individual request is totally separate of all the others. And that's a good thing. That's really easy to scale. That's really easy for reliability. Because now we don't need to worry about, what happens if. We say, well, just fire the request. This core infrastructure will figure out what to do with it. And why? Because it's web scale. Everyone wants to be web scale, right? But fundamentally, it's very stable. So you can fire up, you can shut down servers basically as needed. And if you're using a cloud environment like Amazon EC2, you better get used to that. I mean, servers can disappear, right? Has anyone had a server disappear on them all of a sudden? Nobody? Oh, there's one, okay. It happens. And that's just the nature of the beast there.
It's more fun when they don't disappear, when they just don't work.
Oh, it's more fun when they don't disappear and don't work. Yeah, because you still end up paying for it, don't you? Yeah, okay. Don't do that, that's bad. But it's also very flexible. And so what happens is that if you're running in a system where like server number 1 is getting a lot of traffic, well, each request is separate into itself. You can just shuttle that off elsewhere, and it's not going to matter. And that's all possible because we do not keep the state of anything in the system. We say each one handles its own. Yeah?
Where do we stop, though? Because effectively, if you're storing something in a database, you're storing the state, right?
Well, it depends on what you're talking about.
But my question is still the same.
Generally, databases are not used for those sort of short-term things. Like, it's usually not recommended for like a logged-in status. And this is one of the places where like a logged-in status makes a lot of sense. One of the things I was actually arguing with somebody recently, they were building out an API, and they had the idea of, well, when you retrieve messages from us, we're going to mark these as read. And I said, well, what happens, though, when you've got multiple processes all reading those messages? At some point, as unlikely as it seems, at some point, multiple messages or multiple requests are going to come in for the same message. And if they're dependent on that state, things are going to go screwy. So I would say, if at all possible, don't keep state ever. If you're talking about something that's persisting, like in our case, like a text message, it lives on. I don't think of that as a state, that's a resource. That resource might be able to have states, but the resource itself should be standalone. And so if you think of it in terms of that, then you can sort of dodge a lot of the state stuff. Does that make sense?
I'd have to think about it, but
okay.
We can go on.
Yeah, give me an example.
You basically re-authenticate every time.
Yeah, I'm just talking about...
And this feels weird. Admittedly, this feels really weird. Because it's like, we hate having to log in every time. We hate having to put that in. But you know what? Computers are our slaves. Let's abuse them while we can with the chance. I mean, they're going to take over at some point, so let's just take advantage of it now. All right, the next one, this is the third constraint, cacheable. Ideally, things in our system need to be cacheable at some layer. Now, there's sort of two things that go along with that, and the concept revolves around being idempotent. Careful on how you pronounce that. But what it basically means is idempotent means if I do an action and it changes the state, if I do that action over and over again, that state's not going to change again. So I can do the request one time or n times, and the state's going to be exactly the same. Really easy example of this is making a request for a blog post. You can request that blog post every day, and the state of that blog post is not going to change, or it shouldn't change. I've seen cases where it has, but it shouldn't change. It should be exactly the same every single time. Which means that if something happens and your processes get screwed up and multiple things are requesting the same thing at the same time, you're not damaging the state of anything. You're not damaging the resource in any way. The same goes with a put. A put is sort of used as, does everyone know the HTTP verbs? Get, put, delete, post? Okay, get something. Crazy, huh? Delete something. They're tricky with the naming there. The things where things get kind of squishy are post and put. Post is usually used to create something. So you want to create a text message until you do a post. Now, to do an update, you're supposed to do a put. The problem is, as web developers, we know get and post really well, and we generally only use those. It works. There's nothing fundamentally wrong at that stage. The problem is it sort of muddles things. That's why post is kind of a pain. Because if you're following sort of these Hypermedia API principles, remember, not talking about REST anymore. If we're following these Hypermedia API principles, they're doing a create. It's only doing a create. But the problem is that if we're doing sort of the sloppy web practices that we all know and love, it could be doing a create, it could be doing an update, it could be doing a delete. And we don't know. So we need to be really careful about how we use that. But git, put, and delete are all nice and safe. Does anyone have any questions on that? Idempotent is one of those things that if you ever interview for a job and they do a lot of API stuff, I'm talking about personal experience here. They say, so what is the phrase that means this? And they give you a long definition. In my case, it's always been the textbook definition. You say, oh, yeah, that's idempotent. And they go, oh, wow.
But now get everything's going on the URL line and the post is it has a header and the information is encoded so it can be bigger, right?
If you're talking in browsers, yes. Browsers input.
So get.
Okay, so browsers introduce one set of constraints. Those aren't always the specified constraints.
Okay, so you can use get. You can have it as long as you need to. Yeah.
At some point, you need to stop and ask yourself, what are you doing here? I mean, just like if you had a function that took one parameter, that's probably okay. 2, 3, 4, okay. If it takes 12 parameters, there's something bad going on there. You need to stop and rethink what you're doing. I mean, it's the exact same sort of thing. Are you necessarily doing it wrong? In my opinion, probably. But realistically, you might not be. There might be a legitimate case. But if you're dealing with super long gets, stop and look what's going on. Something hinky is in there. So, what does this look like? Sorry?
Oh, I just said his URLs need to be prettier.
That's right.
Tell Google touch that.
Listen, I know you tune me out most of the time, but just act like you're paying attention. Okay. All right. So what does this look like in practice? This is a URL to a resource for the message list. So if you have a group of SMS messages in Twilio, this is how you interact with that list. So you can do a get. So if you just do without any parameters, it gives you a list of things. You can add a few parameters to sort of filter that. Put is the concept of update, remember? Well, in this particular case, when you create a text message, it gets fired off. So doing an update doesn't make a lot of sense because that message is gone. Doing a delete doesn't make a lot of sense because, well, we need to bill you. At the end of the day, we need to be able to. And post is where we actually do the create step. So if you want to be able to retrieve a message, you do a get. If you do a post, that's creating it, and then it's immutable at that point. You can't change it, you can't delete it, anything like that. But the nice thing is that now we can sort of simplify how we think about things. We know that if we want to interact with this resource, which happens to be SMS messages, everything goes here. We don't need to worry about sort of the RPC SOAP sort of thing of, oh, well, if you're doing this particular action on this class, you have to do it this way. No, it's much simpler. Now we've got a very small interface for each of the things we're interacting with. And that'll become important later on. Another resource is the recording resource. In this case, you've got get, so you can retrieve a recording. You've got delete, so you can delete old recordings. You can't create your own. That's all handled on the back end, like when you make a call. And you can't update them, because it's a recording. How do you update an audio file? Yeah, it doesn't make a lot of sense. There is a school of thought that says that you should implement all these all the time. I think that's dumb. It doesn't make sense. I mean, at some point we have to inject the real world in here, and especially with this case of like text messages. Why in the world should we implement an update? Like, just logically, it doesn't make sense. So some of the people thinking about REST, remember we're talking about Hypermedia APIs, some of the REST guys will say, oh, you need to implement all this. I think they're dumb. That's why we talk about Hypermedia APIs. All right. The next constraint, I believe this is the fourth one, and it's a concept of a layered system. So it's the idea that when we have two pieces of the system, they won't necessarily be talking directly to one another. There'll be things in between them. And those things in between them can be a variety of things. We could have load balancers. A load balancer is a layer between you and the web server, right? And that load balancer has some level of intelligence to be able to say, okay, this request goes here, this request goes there. That's a good thing. That's what we want. In fact, we usually have these on the back end too. How many people use an IP address to connect to their database? A couple people? Does everyone else use like a domain? Yeah. If you think about it, a domain, the DNS system is one of those layers. Because what happens is now that you refer to that server by name instead of by an IP address, now what happens is that layer, that DNS layer, is taking that name, doing a lookup, resolving the IP address, and using that. So it's doing that on the fly. The downside of using an IP address is things change, right? Things change unexpectedly. You might, a lot of times people bring up one server to replace the old one and they run them concurrently for a while, and then they just switch. Well, if it's based on like an IP address, now you actually have to modify the server. If it's based on a DNS entry, what does it take to change an internal DNS entry? It's seconds, right? It's a configuration file. It's not having to sort of reconfigure how that server's working. So layers are really good. And that's sort of the back-end operational ones. But we also have layers like a cache. That's all a cache is. So when we make a request to the cache says, do I have something that's unexpired? Do I have that web page? Do I have that resource? If yes, fantastic, here it is. And since things are idempotent, we can do that. If the back-end system was changing its state every time we requested that page, then the cache wouldn't work, right? Because the cache is intercepting that request and dealing with it itself. So caching is actually a really cool thing, and it's one of these layers. And so, like it or not, we're dealing with this every single day. If you think about it, how many people actually know, well, let's see, think of the top 5 people you call on your phone. How many of their phone numbers do you actually know? Does anyone know all 5? 4? 5 or 4?
Probably 5.
Probably 5. Instead, we don't do that. We have a layer. We have that little name in their phone book. So we use a name, and we look it up, and we place a call. So we're pulling that number, that address, via that. And in some cases, we just look at a picture. We don't even look at a name. So if you think about it, our speed dial is one of these layers. Our speed dial is a DNS, effectively. Or it's a phone name system. I don't know. It's something along those lines. But we use this whether we think about it or not. And this allows us to introduce all kinds of things. So load balancers and caching. A lot of things where people forget is logging and audit trails. If you want to know the requests that are going into the system, adding some sort of layer in between is a really easy way of doing it. Because now you can just log all the requests. And authentication and authorization. You guys know those are separate, right? Not the same thing? Yes? Okay. I'll just believe you do. They're not, but look it up. There's actually a company, Mastery. They're a partner of Twilio. We work with them quite a bit. This is where they specialize in. So you have your API. Best Buy does all their API stuff through them. So instead of you interacting directly with Best Buy, you interact with Mastery, which is one of these layers. They provide the logging and audit trails. And then they basically just forward your request along to Best Buy. Does it introduce a delay? Yes. It's milliseconds though. And so what Best Buy can do as a result of this, well, Mastery goes ahead and takes all this data and they generate reports and they say, hey Best Buy, here's how people are using your API. If you make these tweaks, all these requests go away because it's a simplified request. You can do that sort of thing. You can do that sort of analysis just by introducing some middle layers here. And that's actually a lot of their business model. It's actually pretty cool. And why is this important? Does everyone know what Skynet is? It's your master, right? I mean, Skynet's in charge now, right?
Yeah.
Right. Okay. Does anyone know what Skynet Day was? Nobody? Okay, according to the documentary Sarah Connor Chronicles, Skynet Day was April 21st, 2011. And the way the documentary lays out is that 8:10 p.m. UTC on that day, Skynet came online. Within 6 minutes it was self-aware. Within 4 minutes after that it was nuking us. And so it's funny because in the week leading up to that was a Friday, by the way, and the week leading up to that, everyone was joking around on Twitter, and there was somebody who actually, a girl who had the Sarah Connor handle on Twitter, and somebody started a T1000 handle and was start talking to her, and Skynet started a handle and started talking at her and everything. And this was just some random girl that had no clue. And then she started responding, and it ended up being this whole big thing, going back all week and ha ha ha. And then the 21st happened, and that evening things started going offline. Let's see, PlayStation Network went offline. Yeah. Tumblr went offline. Twitter went offline. All these things start dropping offline at about 8 p.m. UTC that day. And people had this collective, oh shit, what's going on here? Because, you know, like something got not quite as funny. But what happened behind the scenes is the Elastic Block Storage Unit at Amazon East 1, which is outside Washington, D.C. and Dulles, Virginia, went down. And what happened is people weren't using layered systems properly. They had that IP address hard-coded in. So when things started going down hard. They didn't have a way of being able to recover from that, because those IPs just started disappearing off the web. And so you had EC2 went down, and that just US East 1, all of S3 went down. And so like people's Gravatar images were disappearing. The internet was sort of disappearing conveniently from Washington, D.C. So it's like, so that's a bad thing to do, by the way. So actually, Twilio, right around that time, you can see on the 22nd, the next day, Twilio wrote a blog post and said, hey, here's why we didn't have any downtime. And if you actually look at the stats where there was like 15 seconds of downtime in there, it was when, if you already had a call active, you weren't affected. If you were dialing but hadn't finished dialing, you were not affected. If you were dialing and finished dialing during that window, you were affected. Because that's when the connection was made. And so they lost that for a second. So when you dial a phone number and it doesn't work, what do?
Hang up and redial.
Hang up and redial. So the vast majority of people didn't know what was going on. Because they're like, oh, hey, okay, all right. And that was their reaction. And so there's a big blog post on that, and that it comes up again every time EC2 goes down, because people still aren't doing that. We do have some bias in this mix. 2 of our 3 founders were early architects at EC2, so they got pretty good insight into it. But fundamentally, it all comes down to there was not a backup plan. There wasn't that layer to sort of say, oh, we can adjust things on the fly. Netflix actually takes an interesting view. If you're not familiar with me, you should know I'm a big fan of monkeys. And so Netflix has what they call the simian army. The concept is, well, the first monkey of the troop is the chaos monkey. And so they said, imagine that you let a monkey loose in your data center with an axe. Can your system stay up? And so they actually open sourced this just recently. And what it does is it goes out to their Amazon cloud, their EC2 cloud, and starts knocking servers offline. And it checks to make sure that their systems still work. Because you know what? That's how EC2 works. Things might disappear at any given time. They've since expanded the army a little bit, so they have a chaos gorilla. And that's in case an entire data center goes down, which they've gotten a lot more use out of that than I think they wanted. They have a latency monkey, which all it does is it intercepts packets and holds them and lets them go on. Because the system has to handle that. My favorite, though, is the doctor monkey. And the doctor monkey actually looks at Amazon EC2 instances and checks to see their health. And if they're not in good shape, it kills them. And so I emailed them. And I said, isn't that a Kevorkian monkey? I got back, stop it. It's those little things in life that you just have to like. So anyway, Skynet Day. Learn it, remember it, love it. All right, the last constraint, I'm sorry, this is the 5th thing, code on demand. Code on demand is one that developers, we have a hard time understanding. What it basically means is that when I request a resource, when I make a request and I get that page, I'm not just going to get that page, I'm going to get the code to interact with that page. Or I'm going to get the code to interact with that data. And so what's funny is people, we struggle with this one. Because it's like, well, wait a minute. So you're going to give me this code and I'm just going to execute it? So my client doesn't need to have to understand the code, it just needs to have to run it. Does that disturb anybody else? I mean, think of it, you're just running this code that this site is giving you. Does anyone use this? Okay, you're all wrong. Gmail. Gmail gives you what? You should know. What code does it give you?
JavaScript.
JavaScript. So it gives you it gives you a resource, it gives you a page, and it gives you the JavaScript, the code, to actually execute and make decisions and do things and process that page. We do this every day. We don't think about it that way. So code on demand, we struggle with this concept, but fundamentally it's real simple. Here's the data, here's the code. Now they don't have to be like in the same payload. The data can have references to the JavaScript living elsewhere, but isn't it the same thing? And so what's cool is when Gmail upgrades, and we all have to upgrade our browser. No, wait, we don't have to upgrade our browser, do we? Gmail adds a new feature, they add new code. Do we have to upgrade anything? No, because our browser is dumb. At the end of the day, our browser is what?
How come they always ask me to upgrade my browser?
That's Chrome. That's your fault. That's Google's fault. That's not JavaScript's fault. But at the end of the day, if Google wants to add new features to Gmail, they just add it to the code. Our browser doesn't have to change. And once we get to that point, it's really kind of cool because now we can have this like one tool and we can interact with all these applications out there, and the application will provide us the content and the code. And we can call this tool like a browser, because that's what a browser's doing, right? At the end of the day, that's all a browser's doing. A browser's dumb. But it knows how to make a request. That request knows how to include other files or reference other files. We know how to request those files, and then we don't need to know what's in them. We just need to know how to execute them. Does anyone actually know what the insides of jQuery looks like? A couple people? Yeah, well, I expected you to. But fundamentally, we don't need to know. We don't care. As long as our browser can read it, we're happy. So this is one that we struggle with, I think, for lack of imagination. Once we realize what this is actually doing, it's actually really pretty powerful. All right, the last piece is uniform interfaces. And this is actually, I'd say code on demand is probably my favorite thing, but uniform resources I think is the most powerful. So there's 4 pieces that go into uniform interfaces. Uniform interfaces. And so it's the idea that every resource, like every page, every object, whatever, is uniquely identifiable. So we can identify it, we can uniquely identify it. We can say, I want to interact with that object, and that object alone. And what's cool is that we can go ahead and we can manipulate that object through that reference. So just like I had the SMS list up earlier with the SMS messages, we know that we can interact with that object through that interface. Makes things really nice. Self-descriptive messages, which I'll get into quite a bit later on. And then Helios, so the breakfast cereal of champions. Hypermedia as the engine of application state. So we're actually going to go into these in a little more detail. Identification of resources. You can see this is what it usually looks like. This is where we get our pretty URLs. Does it have to be this? Absolutely not. This is actually valid too. The key thing that we need is that these things are uniquely identifiable. We don't care how they are, as long as they are. And so that is, this is what we might see in something like Drupal or any pretty URL sort of system. This is actually the format we use for Web to Project. And what's funny is that people rip us a new one for not having pretty URLs. And it's like, okay, well, first of all, pretty URLs are really great for SEO. We're a project management system that sits behind the firewall. SEO is not high on our priority list. And second, they are uniquely identifiable. We don't need to worry about anything else. They just don't look pretty for you. I don't care. I don't care about you. Who are you? The next thing is that we can manipulate those things through a resource. Because now that we can say, we want to interact with this resource, now we can actually interact with it. And so this is a bunch of the individual resources or objects, if you want to think of it like an object-oriented concept, and how you would interact with them. So you've got calls. You can get all of these. You can post. You can create new calls and new text messages. Not surprising. There's no puts. You can't update anything. And then you can only delete recordings. But the cool thing is, if I add a new resource here, which we do have a new resource out there, but it's not well documented, so I'm not supposed to talk about it yet. But it's in the PHP library if you were interested. Sorry, what was I saying? So if we added a new resource here, like an application resource, how do we interact with it? Well, fundamentally, we know, right? We know that most likely we can get it. And how do we get it? Well, we need to give it a unique identifier and request it by that. We need to decide, okay, can we create one? If we can't, no problem, because we can't create a lot of them. Can we put it? Probably not. We can't update it. Can we delete it? Maybe. But the thing is that once we've sort of written that documentation for the first object, what does it take to write it for the next object? Anything? I mean, all we do is we say, hey, do exactly what you did before except this thing, because it won't work. Right? That's what our documentation is. Or it's the other way around of, hey, do everything you did before, but this one, you can also do this thing. So our documentation just suddenly became much, much simpler. and much easier to maintain, much easier, all that fun sort of stuff. The next key thing is that our messages, the payloads that we're getting back at these requests, have to be self-descriptive. And this is another place where things get kind of squishy. Ideally, the payload that comes back can tell you how to process itself. It can tell you what's actually in there, is it cacheable, and how to get the things that are related to it. And this sounds ridiculously weird, right? I mean, how do we do this? Fundamentally, we're already doing this. When you look at a web page, it has a navigation bar. The navigation bar is just telling you, here's what's available from where you are right now. We know how to process itself. The JavaScript coming down the line is doing that. We don't have to figure that out ourselves. And then if the resource is cacheable, we're already doing that too, right? We have tags that are coming back that says, yes, this is cacheable for this long. Our browser or the web server itself is handling that. So as odd as a concept this sounds like, it's actually much, much easier. Just remember, how to request the next resource, think of it in terms of links. What's linking from the place where I am now? And that comes in really important when we start talking about Helios. I'm not going to read that definition. It's a textbook definition. But basically what it means is that when you have one resource, everything that's connected to it needs to be linked to it explicitly, and it needs to be identified. So you need to say, okay, well, I have this relationship to this other resource. What is it? Now, the cool thing is that ideally the way this works is that we can go ahead and we can add additional things on there, and we can say, like in the concept of Helios, we can say, okay, well, this resource, you can delete it. This one you can't. And so now our client, our very dumb client, can go through all that and say, oh, well, I can delete this one, I can't delete this one. So let me adjust the user interface according to that. Let me adjust the options, the sort of paths available based on that. So what this looks like, and this is kind of a bad example, but the idea is if you can go ahead and you can start from one place and sort of go to the next place, then, well, we should be able to teach a computer to do that, right? So this is actually the root of GitHub, the API. So if you make a request at the beginning of the API and you say, hey, what can you do? It responds back, hey, hit developer.github.com, which is a documentation page. And computers are not good at reading documentation. They're great at generating it, not so good at reading it. They don't do well with verbs and stuff. This is a better one, and obviously this is Twilio, so I'm biased, but what you can do is you can go ahead and request the beginning of the API. So this is from the root of the API. You can say, hey, what can you do? And right off the bat, it gives you some information. It says, hey, look, here's the name of the API, the URI. It says, hey, I've got some sub-resources. There are other things attached to where you are right now. And the sub-resources available are accounts. So what you can do is you can go ahead and hit that, and that's really hard to read. But what it's doing is from the accounts, so you say, I want that accounts link. Give me everything that's there. This says, oh, and here are all the sub-resources attached to that. So now we can go ahead and we can say, okay, well, from where I am, where can I go? And so from here we've got calls, we've got messages, we've got notifications, we've got a whole bunch of things like that. Now, this is considered a pretty good API in terms of it gives you all those relationships, so you can explore them. Where it's weak, though, is it doesn't tell you what that actual relationship is. It just says, hey, these things are linked. Well, that's great, but as the knowability girl was talking about earlier, if you can add sort of descriptive data on top of that, it gets to be really useful. I mean, that's what alt tagging an image is, right? It's adding something additional so that even if you can't see that image, something can make sense of what's there. And that's all we're doing. And we do that via what's called link relations. So when we give one of those links, we say, and here's what it means. So in this case, this is just a snapshot. There's, it's the IA in a link relation list. And it has a whole bunch of ones formally defined. You can add your own, but these are the ones that are out there in all cases. So you can say, current. You can say, this points at itself. If you have a pagination data, you can say next and previous. So you can say, here's how to get the next page, here's how to get the previous. Then you can also do first and last. So if you just want to jump to the first or last thing. I mean, how many times have we written pagination code? A couple times? It comes up regularly. So hey, look, they've got that for you. And the cool thing is, since it's giving you the URLs, you don't have to create them. You don't have to guess what they are. You just say, oh, hey, look, I'm looking for the last URL. Hey, you said this is it. Fantastic. In this particular case, this is a snapshot of the stuff related to a book. So you've got a book. A book has chapters. I'm sorry, it has content. It has chapters. It has copyright. And so what you might have is you've got all these little pieces of information out there. And you've got the book, and it points at one piece and says, that's the copyright. Now the cool thing is you don't need to know what that URL is. You just say, hey, book, what's your copyright? And then the book gives you that URL. It says, here you go. It makes it really nice and simple. So yeah, a chapter can have pages. I mean, it's pretty logical in how they've structured it. And the cool thing is that once we can do that, once we can sort of put descriptors on there, and we can remove the need of guessing what the next URL is, or building the next URL ourselves, that we can have the API tell us, oh yeah, here's your next URL. We can actually build tools that automate this process. And I've built a tool called the REST Spider, which you can go ahead and point it at the root of the Twilio API, and it goes ahead and crawls all those sub-resources from there, and it makes a list of all of them. There's a concept out there. The problem that's with that, though, is that we sort of have a context of where it is and what the relationship is. We don't know how to interact with it yet. And so I actually have a proposal out to a couple groups using the options verb. So we've got get, post, put, head, I don't know, there's a whole bunch of others. One of them is options. Has anyone actually ever, do you even know what options is? Has anyone used it? Okay, good. Options, the whole point of it is this line. Yeah. Represents a request for information about the communications options available on the request. That's the key thing. So now we know how to uniquely identify those resources. We know how they're related to one another. And with options, we can go another step. We can say, okay, resource, what can you do? And then that's when things kind of get exciting. So one of the things I've been dorking around with within Twilio is using options to make sense. Because if we can go ahead and take a resource and say, look, when you interact with this resource, here are the things available. Here are the fields that are required. Here are the ones that are optional. Then you can go ahead and you can, in a lot of ways, auto-document your entire API. And what's cool is when the machines take over, they'll use REST, because this makes a lot of sense. And the computers will be really good at reading this. The problem that you run into here is, like I just saw, no one raised their hand. Very few people are actually using options. I'm doing experimentation within Web Project. We're doing some experimentation within Twilio. I'm sort of leading that. It's not a secret or anything, hopefully, since it's all on video. But we have a sort of opportunity in that we have a very constrained vocabulary. Within Twilio, the parameters we're working with are to and from phone numbers. We've got resources. We've got URLs. We have a body of text messages. That's really sort of those are all of our nouns. We have a very constrained vocabulary. So my theory is if we can get it working at Twilio, and we can get it working in Web Project, then we can use it elsewhere. So I have talked to a number of groups, one in the financial processing space. If we can document a phone call and a text message, and they can document a financial transaction, then we can document a lot of things. We can build a lot of things. And we can have tools that auto-discover APIs. And what's cool is, SOAP's had this for a while, right? I mean, that's what a WSDL is. Does anyone know what it was? Familiar with that? Yeah, I'm sorry. But it's a web description, web service description language. The whole thing is that you use this WSDL, you give it to your code. Your code says, oh, okay, I know how to interact with it now. The problem is that the vast majority of the time, the API and the WSDL, not the same person, right? We've all had that before, right? Well, with this sort of structure, your WSDL now lives within the API. And it's just as up to date as the API is, because it lives right there together. And the cool thing is that as you're exploring this, in theory, you could actually sort of, the concept that we have of active record, of analyzing the database and saying what's there, we could do that to any API too. The problem is, and this is where the dragons come in, everyone's doing their own thing in this space. There is no standard. Like I said earlier, REST is a handshake. This is less than a handshake. This is like that nod you give the neighbor you don't really know. There are big beasts playing in this area, and they're going to get stepped on. I know, because I've already been stepped on a couple times. And they all have their own idea on how things will work. So I'd love to say this is like the panacea. This is how everything is going to be wonderful and beautiful, and when the machines take over, they'll use us. Not quite. We're not there yet. It's a big squishy space at this point. So one of the things we are trying to do to address this is we've got a conference coming up in September. This is the 13th through 15th called Rest Fest. It's in South Carolina. It's like 25 people or so. And some of the best and brightest minds in this. We tried to convince them to call it Hypermedia API Fest. That doesn't flow quite as easily. And they already had the domain name. So, but the whole idea is to be able to explore the concept to go along with this. So I hope to wrap up sort of the options implementation for that and actually present it there and get kicked in the teeth by some of the biggest dragons. We'll see what happens. But if you're interested, it's restfest.org. All the videos from last year are online. Twilio, we sponsored all that, so totally free online. You can grab that. Final notes, if you're interested in some additional resources, Steve Klabnik, a brilliant, brilliant guy. If you ever meet him, he's kind of odd looking, but he's a fantastic guy. He knows he's odd looking, you know. This book here is Building Hypermedia APIs with HTML5 and Node. It's by Mike Amundsen, who actually is one of the organizers of RESTfest. Fantastic book. It uses Node just for the rapid prototyping aspect. It's not like Node heavy. You don't need to know Node back and forth, or backwards and forwards to be able to use it. Let's see, Helios, the serial champions, and we've got the videos again. So with that, I'm done. Once again, I'm Keith Casey. I'm with Twilio. There's my monkey. Any questions?